In section 8.4, we're going to talk about simplifying rational expressions. We've actually already done this in terms of finding vertical asymptotes and wholes. So a rational expression is a quotient of two polynomials, i.e. it's a fraction where there's a polynomial in the numerator and a polynomial in the denominator. What we're going to do is we're going to write them in simplest form. Simplest form occurs when the numerator and denominator have no common factors. So let's look at a general rational expression. In order to put this in simplest form, the first thing we're going to do is we're going to put both the numerator and denominator in factored form if we can. Well, we are. Remember that when you have a trinomial, a quadratic trinomial, a lot of times it can be factored into two binomials by finding the two values that multiply to give you the last term, but add to give you the middle coefficient. Well, the two numbers that multiply to give you -6, but when you add them give you -1, are -3 and +2. For the denominator, the two numbers that multiply to give you -2, but when you add them you get +1, are +2 and -1. Now that it's in factored form, we should notice that the numerator and denominator have a common factor, and that common factor is x plus 2. In the previous unit, that resulted in a whole. So, when I'm done simplifying in simplest form, it's going to be x minus 3 over x minus 1. Now let's go back for a minute and talk about restrictions on the domain. When you have an expression, a rational expression, you need to find the domain before you do your canceling. And it's easier to find the domain in factored form. The domain is x cannot equal -2 or +1. The reason that x cannot be -2 or +1 is because both of those values make the denominator equal to 0. Well, that domain is going to carry over into simplest form. And the other thing I want to mention is that this expression and this expression are called equivalent expressions. We've run across this before. Equivalent expressions are expressions that are actually the same numerical value if you were to evaluate them for a value of x. It's just that they look a little different. Let's try this again. Let's simplify this rational expression and find any restrictions on the variable. In other words, let's find the domain. So, the first thing I'm going to do is simplify the numerator into the product of two binomials. The two numbers that multiply to give me 10, but add to give me 7 are +2 and +5. And in the denominator, the two numbers that multiply to give me -10, but add to give me -3 are -5 and +2. It's at this point in time that I'm going to find the restrictions on the domain, which are that x cannot equal 5, nor can it equal -2. That restriction on the domain carries over to the simplified version of this because these cancel. Remember, in the last unit, that would have given me a whole. And my simplified expression is x plus 5 over x minus 5, with x not being equal to 5 or -2. Multiplication problem is going to work similarly to simplifying an expression. Remember, when you multiply fractions, really all you're doing is you're multiplying the numerators and denominators. But because we have a bunch of polynomials, it would behoove us to write each of these polynomials in factored form and then do some canceling. So I'm going to start with the numerator of the first fraction. There are two numbers that multiply to give you -6 and add to give you +1. Those two numbers are +3 and -2. The denominator, however, is linear, cannot be factored. We're just going to leave it as x minus 5. The numerator of the second fraction is one of our special quadratics. It's the difference of two squares. It factors into x plus 5, x minus 5. And the denominator The two numbers that multiply to give you 3, but add to give you 4, are positive 3 and positive 1. Now remember, there are some restrictions on the domain. I have to look at all the denominators. So my restrictions are that x cannot equal 5, negative 3, or negative 1. And that restriction is going to carry over to the simplified version. So now I'm going to go do canceling. I can cancel the x plus 3's. I can cancel the x minus 5's. And apparently that's all I can cancel. So the final answer is x minus 2x plus 5 over x plus 1 with these restrictions. You don't have to multiply it out. I would just leave the final answer in factored form. It's going to make your life a lot easier. Just like we learned in middle school, dividing by a fraction is the same as multiplying by the reciprocal. And it's always the reciprocal of the second fraction. So I'm actually going to rewrite this as a multiplication problem by flipping the second fraction. Now we find out that this problem, even though it's division initially, it's really just the same as problem 2. The first thing that I'm going to do is I'm going to go and I'm going to factor everything, and then I'm going to do a bunch of canceling. After I'm done factoring, I'll go find my restrictions because I need to find them before I cancel. This is the first thing that I want to point out to you. Yeah, I don't like 2 minus x. I'd rather that said x minus 2. Because a lot of times people don't recognize some things that can be canceled. 2 minus x is the same as negative x minus 2. All I did was factor out a negative 1. That means I divided these both by negative 1. And when you factor something out, you write it in front of a set of parentheses. Well, when I divide both of those, I get a negative 2 and a positive x. And I flipped it and wrote it as x minus 2. The reason we're going to do that is because otherwise we're going to miss something that can probably be canceled. So I'm going to point this out to you. I'm going to put a big star here. I want you to notice this because it will come back to haunt you again. So watch out for things that are in the reverse order of what you'd like them to be in, because you can usually solve the problem by factoring out a negative 1. All right, now I can factor the denominator. The denominator factors into x plus 1, x plus 1. This is our special difference of two squares. It factors into x plus 1, x minus 1. And the last polynomial factors into x plus 5, x minus 2. Because 5 times negative 2 is negative 10, 5 plus negative 2 is positive 3. Now I'm going to do my restrictions. My restrictions are that x cannot equal 1, nope, negative 1, negative 5, and positive 2. Now let's go cancel. Look, I can cancel those x minus 2's, and I can cancel some x plus 1's. That appears to be all I can cancel. So I'm left with negative x minus 1 on top. Where did the negative come from? Right there. Over x plus 1, x plus 5, and this is still the restriction.